Hi everyone, today we will revise all past paper questions from 2016 to 2024 related to chapter 9, Reversible Reactions and Equilibrium. Before starting this question, I will give you a brief introduction related to this chapter and then we can start our question. So, as we already know that most of the chemical reactions are not reversible, right? They are irreversible reactions, but still we have some reactions that can be reversed. And these reversible reaction, what does it mean? It means that you can get back your reactants again from the product. One of the example is this, the production of ammonia. When you produce ammonia, this reaction can be the ammonia can be decomposed into nitrogen and hydrogen again, and you can get back your reactants. So see, such reactions are reversible reaction. But there are so many important reactions, such like the production of ammonia, that need to be carried out in a closed system. So when you carry out some experiment or some reaction in a closed system, the reaction will be reversible. A time will come that the production of ammonia and the production of nitrogen and hydrogen will be same at the same rate. So that position is actually called equilibrium. Equilibrium is the position at which the forward reaction and the backward reaction are taking place at the same time. Okay, so last time when we were doing chapter 8, I told you there are some factors that can affect the rate of reaction, and those factors that can affect the rate of reaction, what does it means? That can speed up the reaction are the speed of the reaction are temperature, pressure, and then we have concentration, right? And also addition of a catalyst. These are the four factors that can affect the rate of the reaction. Addition of the catalyst, and in concentration we have two: concentration for solutions and surface area for the solid, right? Okay, but when it comes for reversible reaction and we get the equilibrium, there are some reaction, for example, the production of ammonia, we don't want the reverse reaction, right? We don't want nitrogen and hydrogen back. So what we should do for this purpose to change the equilibrium position, because a time will come in a closed system when the production of ammonia and nitrogen and hydrogen will be equal. So it means we will not get our product ammonia, right? So for that purpose, what we should do, we should change the position of equilibrium. What does it means? This is actually the reaction when it starts, the reactant side, because this is the left side, so we call it the left side of the equilibrium. And this is the product. So it will be called as the right side of the equilibrium. So we have to, our main target is to shift the equilibrium at the right side. So what are the factors that can affect the equilibrium position? The factors are same like the factors that can speed up the reaction, except for addition of the catalyst. Addition of the catalyst has nothing to do with the equilibrium position. Its job is only to speed up the reaction. But if you increase the temperature, if you increase the pressure, only if there are gases in the reactant and the solid, okay? And if you increase the concentration, it depends, concentration of reactant or the product, then your equilibrium position can change. Okay, so these are the three factors: temperature, pressure, and concentration, that can affect the equilibrium position. According to Le Chatelier's principle, I will tell you how these factors can affect the equilibrium position. Okay, so we can see one by one each three the factors that can change the equilibrium position. Okay, so let's see the factors that can affect equilibrium position. Okay, so there are three factors that can affect the equilibrium position. So we can see one by one. One is pressure. Okay, only for the gases. If we have reactant and the products are gases, then we have temperature, and then the third one is concentration. So concentration is simple. If you have reactants and this is your product, right? And if this is now equilibrium position, if you add more reactants, if you increase the concentration of the reactants, the product will be made more, because the system will try to reduce these reactants. So our position will shift towards right. Why right? Because now we have more reactants in the system, so the system will try to make the equilibrium position again, and it will try to make more products. So whenever, if you want the position to be shifted towards the right, you have to add more reactants again and again. Or the other thing we can do is to remove the product. If the product number will be less, the system will think, okay, the product is less, let me try to make more so I can get the equilibrium back. So it will try to make more product again if you remove the product. So if you want to remove the product, or if you add more reactants, the equilibrium will move towards the right. So this is for concentration. Let's see about temperature. Temperature has nothing to do with the concentration of the reactants and the products. Temperature actually depends on two, we already have discussed that there are two types of reaction, endothermic and exothermic. So the temperature always favors the endothermic, because endothermic likes the heat, right? Endothermic means to absorb the heat, the reaction that needs the heat. So if any reaction is endothermic in the forward, it means the reversible reaction will be exothermic. So if our forward reaction is endothermic, so we have to increase the temperature. If you increase the temperature, you will get more products because of the temperature, because temperature, endothermic always are favored by the temperature. But if you increase the temperature for exothermic, the forward reaction is exothermic, what will happen? The product will not be made. Instead, the reactant will start making, okay, product will start making the reactant. So it means for exothermic reaction, you cannot increase the temperature. Increasing temperature will increase the rate of reaction, but it will not increase the product yield, because the reaction was exothermic, okay. So exothermic always like the low temperature, whereas endothermic likes the high temperature. So this is the one thing. Now let's come toward the pressure. According to Le Chatelier's principle, if the pressure depends on the concentration, or you can see the number of moles of the gases in the reactants and the products. For example, your two moles of the reactants are here in this reaction or in this equation, and you see the product is just one. And if you at now, this is the stage of equilibrium. So if you want the equilibrium to move towards the right, what you have to do, you have to increase the pressure. Why? Because increasing pressure always help the one that is less in number. Which one is less? We have only one product, one mole of a product, but we have 2 moles of the reactant. It means the product number is less. So what will happen if you increase the pressure? You will get more product now, because the product will be less, things are favored by pressure. Pressure always, increasing the pressure will favor the one that is less in number. But if you decrease the pressure, it will favor the reversible reaction, because decreasing pressure will always help the one that is more in number. So this is all related to this chapter. So now when we will cover the questions, it will be more clear to you. Let's see question 1. Which reaction is reversible? An iron nail rusting when left in moist air? Of course not. You cannot get back the iron. It will once it is rusted. Limestone reacting with an acid to form carbon dioxide. It's also irreversible reaction. Magnesium burning in air to produce white ash. All burning reactions are mostly irreversible. White anhydrous copper sulfate turning blue when water is added. Yes, this reaction is reversible, because copper sulfate is a salt that is present in two forms, either in the hydrated form or in the anhydrous form. So if it is anhydrous, then it is white color. But when the water is added into it, it becomes hydrated and its color change to blue. Okay, so that's why the anhydrous copper sulfate, when it turns into blue when the water is added, it's a reversible reaction. You can reverse it back by heating these blue crystals. When you will heat it, the water will evaporate and you will get back your white crystals again. So that's why D option is the right option. Question 2. When the colorless gas N2O4 is heated, it forms a brown gas. Okay, when the reaction mixture is cooled, the brown color fades and turns back to colorless. So it means when the reaction was heated, it was a reversible reaction. Okay, why reversible reaction? Because only the change in the temperature is giving back the reactants again. If you see, before, a colorless gas was heated, and when the same temperature was, the mixture was cooled down, the brown color fades and turns back again to colorless. It means we get back our N2O4 gas. It means this reaction is also a reversible reaction. Okay, not a decomposition, displacement, or reduction, because these reaction you cannot get back your reactants, but it's already given in the statement that you will get back the colorless gas again when the temperature was cooled down. So option D is the right option. Question 3. When a green crystals of nickel sulfate are heated, water is produced and a yellow solid remains. Okay. Water is produced and a yellow solid remains. When water is added to the yellow solid, the blue-green color returns. So what does it mean? That it is a hydration reaction actually, in which once you added the water, the color will change, and when it is heated, the water will evaporate and the color will change again. So it means it's a reversible reaction in which the addition of the water or heating the same reaction can change the reaction to forward or backward, forward or reverse. So that's why this is also a reversible reaction. Question 4. When hydrated copper sulfate is heated, it produces white copper sulfate. When water is added, the white copper sulfate turns blue again. So what does it mean? This reaction is also a reversible reaction. Okay, let's see question 5. The equation shows the formation of anhydrous copper sulfate from hydrated copper sulfate. Okay, so you can see this reaction. This is the hydrated one. And then when you heat it, you will get the copper sulfate and the molecules of the water. So statement 1, 2, and 3 refer to this reaction. So let's see, hydrated copper sulfate is reduced to anhydrous copper sulfate. The reduce word is wrong because this is not an oxidation reduction reaction. This is just simply a hydration reaction when water is added or when water is removed or it is added. Okay, so it's just a hydration reaction in which water molecules are added or removed. So the first statement is wrong. The 2 is the name copper 2 sulfate refers to the oxidation state of the metal. Yes, that's right, because it is written in front of copper. So it means the oxidation state of copper is 2 plus. So this is the right statement. The reaction is reversible. Yes, right, because we have a reversible symbol. So which statements are correct now? 2 and 3 are the right statement. That is option C. Question 6. The equation show a reaction that is reversed by changing the condition. How can the forward reaction be reversed? So this is our forward reaction in which we have given the heat, right? Because it was before hydrated and then it becomes anhydrous one. So what we can do to reverse it? So what we can do is that in this anhydrous, we can just add this water. Okay, the addition of the water actually, it's already written here, will change it back into the hydrated copper sulfate. So by adding water, yes, and by heating, of course not. We cannot heat it, because if we heat it, it is actually in the forward reaction we have to heat it. So it's just addition of the water will reverse this reaction. So option B is the right option. Question 7. When copper sulfate is heated, a white solid and water are formed. The white solid turns blue and gives out heat when water is added to it. Which term describes the blue copper sulfate and the reaction? So blue copper sulfate is what actually? A blue copper sulfate is not a mixture. Actually, it's a hydrated solution. It's a hydrated salt. So hydrated option is right because the water is added or removed. So the blue color copper sulfate, when it is heated, a white solid and water is formed. It means it was hydrated. So hydrated water is, now the water is removed. So this was actually a hydrated one. Reaction. What about the reaction? So out of these, can be reversed or cannot be reversed? Yes, it can be reversed, because when you heat it, you can get back the anhydrous one. And when you add the water, you can get back again the blue copper sulfate. So the reaction can be reversed. So option C is the right option. Question 8. P is a hydrated metal salt with a blue color. When P is heated, water is given off leaving solid Q. So once we have one P solid and the other one is solid Q. R is a hydrated metal salt with pink color. Okay. So when R is heated, water is given off leaving solid S. So it means it is anhydrous one and this is hydrated one. R is hydrated one because it's pink color, and when you heat it, it changes the color. So it is hydrated one. Okay. So name of the P. So P, if you see here, it is a hydrated salt with the blue color. And which salt is blue color when it is hydrated? It's actually copper sulfate. So copper sulfate is the right option. It's a hydrated metal salt, so it's a hydrated copper sulfate. So these two options are the right option. And then which row gives the name of the P? So we already have given the name of the P and the color of the S. So what will be the color of the S? The R is a pink color hydrated, which is cobalt chloride. Cobalt chloride, when it is hydrated, is pink color. And when you heat it, the water will be evaporated and the color of the anhydrous cobalt chloride will be now blue. Okay. So anhydrated cobalt chloride will be blue in color. So blue is the right option. So that's why option C is the correct option. Question 9. Solid X is heated strongly. The color of the solid changes from blue to white. What is solid X? So blue is what? Hydrated copper sulfate. You need to remember this one, that copper sulfate salt actually is a blue color when it is hydrated, when it has water molecules. When there is no water molecules, then it is white color. So this is actually hydrated copper sulfate. X is a pink solid, Y is a blue solid. When X is heated, water is produced and the solid turns blue. So what does it mean? X, if it is a pink solid, it means it's a cobalt chloride. And which cobalt chloride? Of course, hydrated one. Hydrated cobalt chloride is always pink color. Okay, so it's pink color. And the other one, Y is a blue solid. Okay, so Y is a blue solid. It can be anhydrous cobalt chloride because it is also blue color, or maybe there's another option, that is hydrated copper sulfate, that is also blue color, right? So we can see that which one. Okay, when X is heated, okay, hydrated cobalt chloride is heated, water is produced and the solid turns blue. Okay, yes, that's right, it will change into Y, right? Or anhydrous cobalt chloride. When water is added to Y, so if you add the water to the Y, okay, which is blue color, right? So the color, the solid turns pink. So who can turn pink? When in hydrated copper sulfate is already blue. If you add more water, the color will remain the same, right? Because it's already hydrated. So it's only possible in the, when you add the water in the blue anhydrous cobalt chloride, then it will turn into pink. So it means they both are cobalt chloride. One is hydrated and the other one is anhydrous. So X is hydrated cobalt chloride. So here, okay, this is the only option we have already here. So the Y is anhydrous cobalt chloride. So option B is the right option. Question 11. Which statement about a reaction in equilibrium is correct? So I already told you that equilibrium is the position or the when forward and backward reaction are taking place at the same rate. Okay. So see the options, both the forward and backward reactions are proceeding at the same rate. Yes, this is the right option. Let's see the option 2. Neither the forward nor the backward reaction is proceeding. That's wrong. Reaction never stops in the equilibrium. Actually, it is taking place but at the same rate. What does it mean? It means at the same time, if the one nitrogen and one hydrogen molecule is giving one ammonia, then at the same time, this ammonia is giving you back the hydrogen and nitrogen. So if you see with the naked eye, you will see that the reaction is not actually proceeding, but actually it is proceeding, but with the same rate. That's why you cannot see any product or any reactant. You can just see the same amount which you have added already. Okay, so that's why this statement is wrong. The amount of the product present is no longer affected by changes in temperature or pressure. Wrong. At equilibrium, you can change this now. We can change the product the amount of the product, or also the amount of the reactant at this time. Okay, if you change the pressure or the temperature, the amount of the product present is only affected by change in pressure. Wrong. It can also be affected by the temperature, it can also be affected by concentration. Okay, so only option A is the right option. Question 12. Hydrogen is produced when methane react with steam. Okay, this is the reaction. The forward reaction is endothermic. Which condition produce the highest yield of hydrogen? So when the forward reaction is endothermic, according to Le Chatelier's principle, endothermic are always favored by high temperature, right? So if you increase the temperature, you will get more product, because they are asking about the highest yield of hydrogen, and hydrogen is our actually at the right side. So we have to shift the equilibrium at the right side. So right side means we have to give high temperature. So where is high temperature? Yes, these two options are right. Now let's see about pressure. Should we increase the pressure? Yes or no? That depends. How many molecules we have of the gas in the product? We have 4 molecules, right? But here we have only 2 molecules. So if you increase the pressure, it will always the favor that is less in number. So it means it will favor the reactants. So we don't want to favor the reactants. So what we should do, we should decrease the pressure now. Okay, so the pressure should be lower. That's why option C is the right option. Question 13. Methane react with steam and an equilibrium is reached. The forward reaction is endothermic. Again, it's endothermic. So which row shows how the amount of hydrogen at equilibrium changes when the pressure or the temperature is changed as indicated. So if you decrease the temperature, let's see, the amount of the hydrogen will increase. That's wrong because it's endothermic. If you decrease the temperature, it will not increase the hydrogen amount. So that's wrong. If you increase the temperature, it will decrease the amount of the hydrogen. Yes, that's right. Okay, if yes, sorry. If you increase the temperature, then it should increase the amount of hydrogen. So this statement is also wrong. Now let's see for no change, no change. We are only left with this option. So let's see for the change in the pressure. So if there is no change in temperature and if you increase the pressure, let's see now increasing the pressure will have how much effect on which side. How many number of moles of product we have here? 3 and 1 is 4. Here we have 1, 1. So it's total 2. So we have 2 moles of reactants and 4 mole of the product. So it means if you increase the pressure, it will favors the reactants, not the product. But they are asking about the hydrogen, the amount of hydrogen. So it means if you increase the pressure, the hydrogen amount will be less. So if you increase the pressure, the amount of hydrogen will be decreased. So this option is the right option. So that's why option C is correct. Question 14. Methane react with steam to produce hydrogen and carbon monoxide. The equation for the reaction is shown. The reaction is reversible. The forward reaction is endothermic. Again, the reaction is endothermic. It means high temperature will favor the forward reaction. So, which changes in temperature and pressure increase the equilibrium yield of carbon monoxide? So, carbon monoxide is on the right side. So, it means the forward reaction we have to increase. So if carbon monoxide is on the right side, so increasing the temperature will favor the right side because the forward reaction is endothermic. So forward means it will help the right side. So it means high temperature is the right option. Where is, okay, increasing the temperature. Let's see about the increasing the pressure. How many molecules of the gas we have here? 1 and 3, 4. Here we have only 2. So if you increase the pressure, it will not favor carbon monoxide because we already have more numbers of the gases in the product. So it will favor this one. So what should we do? We should decrease the pressure so it can favor the more number of moles. Decreasing pressure always favor the one that has more number of moles. So you decrease the pressure, so it is that's why option C is the right option. Question 15. The reversible reaction between methane and steam is shown. The forward reaction is endothermic, which changes in pressure and temperature move the equilibrium to right. Right is this side, so it means we have to move the equilibrium towards the forward reaction or the right side. Okay, so what should we do? If the reaction is endothermic, it means we should increase the temperature. If you increase the temperature, the reaction will move towards forward. And the second thing is about the pressure. So for pressure, we have to count the number of moles. We have 4 here and here we have 2. So if we want to favor this side, the forward side or the right side, then we should decrease the pressure because decreasing the pressure will helps the one that are more in number of moles, right? The gases which are more in number of moles, it will be helped by the decrease in the pressure. So decreasing the pressure is the right option. So this option is the right option, that is option B. Question 16. The equation represents the reversible reaction between ethene and steam. Okay, delta H is negative. What does it mean? It means the reaction is exothermic. They have not told you that the reaction is exothermic or endothermic, but they already have give you enthalpy change. And enthalpy change is a negative. So it means this reaction, the forward reaction is exothermic. Because whenever they are giving you the information, they are giving you about the forward reaction, not about the reverse reaction. So which row describe the conditions that produce greatest yield of ethanol? So ethanol we are getting in the forward reaction. So if the reaction is exothermic, it means we have to give low temperature, because low temperature always favors exothermic reaction. So the temperature should be lower. These two options are right. Now let's see about the pressure. How much the pressure should be? How many moles we have of a gas here? 1, 2, right? So we have 2 moles of the gas here, and on this side we have just 1 mole. So it means if you increase the pressure, it will help the one that is less in number. And what is less in number? Of course, ethanol. So we should increase the temperature, increase the pressure. Okay, increasing the pressure will help the ethanol production. So we will have highest yield of ethanol if you have high pressure and low temperature. So this option C is the right option. Question 17. Hydrogen is made by reacting carbon with steam. The equation for the reaction is shown. The reaction is endothermic. Okay, so if the reaction is endothermic, the forward one, so it means high temperature will favor this reaction, the forward one, which will describe the changes in pressure and the temperature that will both shift the position of the equilibrium to the right. To the right means we want the reaction to be in the forward direction. So again, if it's endothermic, we have to increase the temperature. Second, for pressure, we have 2 mole of the gases here, 1 and 2, and here we have 1 mole of a gas. This is not a gas, this is a solid, okay? So pressure has nothing to do with the solid, it only has to do with the gas. So if this side has 1 mole of a gas, it means, but we want the equilibrium towards the right side. So it means what we should do? We should decrease the pressure, because decreasing the pressure always help the one that is more in number, and 2 is more in number. We want this reaction to be in the right side, right? More production of carbon monoxide and hydrogen. So for that purpose, we should decrease the pressure. So decreasing the pressure is the right option, that is option B. Question 18. Steam reacts with carbon in endothermic reaction. Which conditions of temperature and pressure will give the highest yield of the hydrogen? So hydrogen is on the right side. It means we have to shift the equilibrium towards the right side. And the reaction is endothermic. So it means it will be favored by high temperature. So we have to give high temperature. These are the right option. And what about the pressure? So pressure, how much we should give? We have 2 moles and we have 1 mole here. So it means we should give low pressure so that it can favor the right side. So low pressure and high temperature will be the right option. That's option B. Question 19. Methanol is prepared by reversible reaction. The forward reaction is exothermic. So it means low temperature will favor the exothermic reaction. Which condition produce the highest equilibrium yield of methanol? So if the temperature is lower, it will produce high yield of the methanol. Now let's see about the pressure. How much pressure we need to change the equilibrium towards the methanol to the right? So it's 1 mole, but here these are 3 moles. So it means increasing the temperature, increasing the pressure will favor the one that is less in number. So we can increase now the pressure, because if we increase the pressure, more methanol production will take place. So increase the pressure, high pressure. So C option is the right option. Question number 20. In the Haber process, nitrogen and hydrogen are reacted to make ammonia. The forward reaction is exothermic. Which condition produce the maximum yield of ammonia? So how we can get maximum yield of ammonia? If we give low temperature, because the reaction is exothermic. So the temperature should be lower. And what about the pressure? Because there are 2 moles of ammonia here and we have 4 moles of the gas in the reactant. So it means increasing the pressure will favor the one that is less in number. So it means we will get more ammonia if you increase the pressure, because ammonia is already less in number of moles. So increasing the pressure and lowering the temperature will favor the high yield of ammonia. Option B is the right option. Question 21. The decomposition of dinitrogen tetroxide into nitrogen dioxide is a reversible reaction. The equation for the reaction is shown here and it's an endothermic. Okay, which row shows the effect of the position of the equilibrium and the rate of reverse reaction when the temperature is increased. So this is endothermic reaction. So if the temperature is increased, of course, it will favor the production of the nitrogen dioxide. So position of the equilibrium will shift towards, of course, right side if you increase the temperature. Okay, so it will shift towards the right, because this is our right side. And rate of the reverse reaction. What about the reverse reaction? The rate of the reverse reaction will be decreased now. It will decrease because the equilibrium shift towards the right. So when it shifts towards the right, it means the left side has been decreased, and left side is actually our reverse reaction. So option C is the right option. Question 22. Dinitrogen tetroxide is converted into nitrogen dioxide is a reversible reaction. The reaction is endothermic. Which conditions give the highest equilibrium yield of nitrogen dioxide? So, to get nitrogen dioxide, we have to shift the equilibrium towards the right again. And to shift the equilibrium towards the right, the forward reaction is endothermic. So, it means you have to give more temperature so it can go again in the right direction. So, high temperature will help this one. And what about the pressure? The pressure should be lower because this one is more in number. So, if you decrease the pressure, then it will favor this side, because if you increase the pressure it will favor the less in number, so you will get more reactants, and we don't want more reactant, right? We need this product, so we have to decrease the pressure. So where the pressure is, this option is the right option, the lower pressure. Okay, so option A is the correct option. Question 23. At room temperature, the conversion of nitrogen dioxide into dinitrogen tetroxide is reversible. The forward reaction is exothermic. Okay, so this reaction is exothermic. So which changes cause the equilibrium shift to the left? So the equilibrium we have to shift now towards the left. It means we have to get back the reactants. So if this reaction is exothermic, then this is endothermic, the reverse reaction. So if the reaction is endothermic, it means we have to give high temperature, okay? Because according to them, we have to shift the equilibrium backwards in the left side. So we have to increase the temperature. So increase the temperature is the right option. And what about the pressure? These are the number of moles of the gas are 2 and here are the 1. So if you increase the pressure, it will help N2O4, but we don't want right side this time. We want the left side, right? We have to shift the equilibrium towards the left side, and left side has more number of moles. If they have more number of moles, we should decrease the pressure. So the pressure should be decreased so that we can get the equilibrium towards the left side. Okay, so decrease the pressure and increase the temperature will favor this reaction, that is option B. Question 24. Two molecules of nitrogen dioxide combines in a reversible reaction to form dinitrogen tetroxide. The forward reaction is exothermic. Which changes in reaction conditions would both increase the amount of dinitrogen tetroxide at the equilibrium? So if the forward reaction is exothermic, it means we need lower temperature, the decrease in the temperature. So these two options are the right option. Increasing the temperature will not favor the forward reaction, right? Because they are asking about the forward reaction, dinitrogen tetroxide. Now let's see about the second option, decreasing the temperature and decreasing the pressure. If we decrease the pressure, it will favors the one that is more in number. And which one is more? Of course, this one. So we don't have to favor the nitrogen dioxide. We have to favor the dinitrogen tetroxide, and it is less in number, right? So we have to increase the pressure. So increasing the pressure is the right option, that is option B. Question 25. A reaction between nitrogen and oxygen is shown. The forward reaction is endothermic. Which change increase the equilibrium yield of nitrogen monoxide? So we have to increase the yield of nitrogen monoxide. It means we have to shift the equilibrium towards the right side, or we have to increase the forward reaction. And forward reaction is endothermic. So it means we can give high temperature. High temperature will favor the endothermic reaction. So do we have any option of increasing the temperature? Yes, option D. So option D is the right option. The equation shows the equilibrium between dinitrogen and nitrogen dioxide, NO2. The color of the reactant and the products are also shown here. So the forward reaction is endothermic, which statement is not correct. Okay, so this forward reaction is endothermic. Let's see, at equilibrium, the concentration of the reactants and the products are constant. Yes, that's right. At equilibrium, the concentration of the reactant and products is always constant. What does it mean? It means if one reactant is giving you two product, then two product will give you back the one reactant, right? Okay, it will give you one reactant. You cannot write the word equal. If you say it's equal, that's wrong. Equal means 2 moles is equal to 2 mole. That's not right here. 1 mole is giving you 2 moles of the product, and 2 moles of the product will give you 1 mole of the reactant. So it means the ratio is constant. It's not equal. So equal word is not right for the concentration of the reactants and products at equilibrium. Okay. The rate of the reaction is equal. The rate of forward and reverse reactions are equal, but the concentration of reactants and products, that they are constant. Okay. So at equilibrium, the concentration of the the concentration of the reactants and the products are constant. So that is the right option. At equilibrium, the rate of the forward reaction is equal to the rate of the reverse reaction. Yes, the rate of forward and the reverse reaction is equal. Okay. When the pressure is increased, a dark brown color is seen. So if we increase the pressure, let's see, increasing the pressure will help the one that is less in number. And which one is less? Of course, this one. It is only 1 mole. So it means if you increase the pressure, it will favor the colorless gas. But they are saying it, we can see more dark brown color. That's wrong. We cannot say see this one more. Okay, because we are increasing the pressure. So it means this is not correct option. When the temperature is increased, a dark brown color is seen. Okay, so if you increase the temperature, yes, that's right, dark brown color will be seen because the forward reaction is endothermic. So this is the only wrong option, that is option C. Question 27. Hydrogen gas reacts with iodine gas to form hydrogen iodide gas in equilibrium. Okay, this is the reaction. Which changes increases the yield of HI at equilibrium? Adding a catalyst. I already told you that catalyst only increase the rate of the reaction, because if you add the catalyst, it will increase the forward reaction also and the reverse reaction. So the rate of the reaction will only be increased, but it will not affect the yield of the product or the reactant. So adding a catalyst will not increase the yield of HI. Adding more hydrogen gas. Yes, this one is right, because you are adding more reactant now. So if you are adding more reactant, then the reaction will shift towards the right to produce more product, and that is our requirement. We have to increase the yield of HI. So option 2 is the statement 2 is right. Increasing the pressure. So if we increase the pressure, what will happen? There will be no effect. If you see, we have 2 moles on both sides. So increasing the pressure will have no effect. So that's why this option is also not right. Increasing the temperature. Increasing the temperature, yes, it can increase the yield of the hydrogen iodide. Why hydrogen iodide yield will increase? Because if you see, there is a positive sign for the enthalpy change, which means this reaction is endothermic. So endothermic are always favored by increasing the temperature. So option 2 and 4 are the right option, that is option D. Question 28. Hydrogen reacts with iodine to form hydrogen iodide. Which statement explain why the reaction is faster when the pressure is increased at constant temperature? Okay, so why the reaction will be faster when the pressure is increased? Okay, so now they are not saying that the product will be increased, right? They are just saying that the reaction will be faster. Yes, that's right. The temperature, the pressure and the temperature and also the concentration, they increase the speed of the reaction. Okay, so let's see, at higher pressure, the more molecules are moving faster. Wrong. The molecules move only faster when the temperature is increased. At higher pressure, more of the molecules have the required activation energy. Again, wrong. At higher pressure, the molecules are close together. Yes, because when you give more pressure, there will be less volume, so the particles will come close together. At higher pressure, the molecule collide more frequently. Yes, that's also right, because when they are more close together, they will collide more frequently. So option 3 and 4 is right. That is option D. So option D is the correct option. Question 29. At 400 degrees Celsius, the reaction between hydrogen and iodine reaches an equilibrium. The reaction is exothermic, okay? Which changes in the condition would increase the percentage of hydrogen iodide in the equilibrium mixture. So when the reaction is exothermic, it means you have to give low temperature, right? So can we see a decrease in temperature? Yes, a decrease in temperature is the right option. So option B is correct. Chlorine can be manufactured by the following reaction. The reaction is exothermic. Okay, which changes increases the yield of chlorine at equilibrium. So where is chlorine? Of course, it is in the product. So we have to shift the equilibrium towards the right. The reaction is exothermic. It means that exothermic reactions are favored by low temperature. So if you decrease the temperature, then we get more chlorine. But we don't have an option of decreased temperature here, right? So this one is excluded. Now let's come toward the pressure. So if you see, the number of the moles are 5 here, and here we have 4 moles. So if you increase the pressure, it will favor the production of the chlorine. Okay, so increasing the pressure, can we see any option? Yes, it's also not here. So it means these two are wrong. Now let's see for the concentration. Concentration is only the left option. So if you increase the reactants, you will get more product, and your product is chlorine, right? So increasing, is there any option for increasing the HCl or O2? Adding more HCl, yes, we have the option of adding more HCl. So option A is the right option. Question 31. When bismuth chloride BiCl3 reacts with water, a white precipitate of the bismuth oxychloride is formed. The equation for the reaction is shown. The reaction is in equilibrium. Which changes causes the white precipitate to dissolve? So you see, we have white precipitate here in the product, because all other are solutions, and this one is the only solid here. So if you adding acid, if you add more acid, yes, that's right. So this option is right. Why? Because the equilibrium will shift towards the left if you add more acid. So if we, when it moves towards the left, this precipitate will dissolve and you will get back again BiCl3, right? So adding acid is right. Adding water, if you add more water, it will shift towards the right again. So that's not the right option, because we will get more precipitate. So that's not right. Adding sodium chloride solution. So if you add more sodium chloride solution, what will happen? Actually, HCl will react with the sodium chloride. So what will happen? More sodium chloride, NaCl. So you will get more chlorine also, right? HCl and NaCl, you will get more sodium and chloride ions. So when you have more chloride ions, again the equilibrium will shift towards the left side. So that's why the option 3 is also a right option. So 1 and 3, that is option B. So option B is the correct option. Question 32. When BiCl3 reacts with water, a white precipitate is formed. The equation for the reaction is shown. Which statements are correct? The reaction is reversible. Yes. When dilute HCl is added to the reaction mixture, okay, more of the white precipitate forms. Wrong. Because if you add more product, it will shift towards the left side, right? So you will get less now white precipitate. When aqueous sodium hydroxide is added to the reaction mixture, more of the white precipitate forms. Okay, so if we add more NaOH, right, sodium hydroxide, we will get more of the white precipitate. Yes, that's right. Because NaOH, when we will have more, if you see here, we have more OH in the reaction here, then what will happen? Because then we will get more of this product, right? And even because Na will react with the Cl, you can get, so the Cl number will reduce again. So that's why we will get more product again, because in the product the Cl number is decreased. So that's why option 1 and option 3 are the right option. That is C. Question 32. When carbon monoxide reacts with hydrogen, methanol is formed. The forward reaction is exothermic. Which statements are correct? There are more moles of gas on the left hand side of the reaction. So let's see. This is the left hand side. Yes, we have 3 moles here, and here we have 1. So this is right. Increasing the temperature increase the amount of the methanol at equilibrium. Methanol is on the right side and the forward reaction is exothermic. So it means low temperature will favor the production of methanol. So this is increasing the temperature. That's wrong. Increasing the pressure increases the amount of the methanol at equilibrium. Yes, that's right, because methanol is 1, and if you increase the pressure, it will favor the one that is less. And there we have 3 moles. Here we have 1 mole. Increasing the initial amount of hydrogen, okay, if you increase the initial amount of hydrogen, it decreases the amount of the methanol at equilibrium. That's wrong. Why? Because if you increase the reactants, you will get more product. So only option 1 and 2 are the right option. So option A is the option, sorry, 1 and 3 are right. So option B is the correct option. Question 34. Methanol is manufactured by reacting carbon monoxide and hydrogen together in the presence of aluminium oxide catalyst. The equation for the reaction is shown here. The reaction is reversible reaction, and the reaction is reversible reaction. Yes, we can see here from uh, this arrow, and the forward reaction is exothermic. Okay, so the forward reaction is exothermic. Which change in condition increase the yield of methanol? So if you increase the temperature, it will not favor the forward reaction, right? Because the forward is exothermic. If you increasing the rate of the reaction, increasing the rate of the reaction has nothing to do with the increasing the yield, right? So that's also wrong. Increasing the pressure, yes, increasing the pressure can favor methanol because methanol moles are less compared to the reactants. So increasing the pressure is the right option. Or decreasing the concentration of carbon monoxide, again wrong. If you decrease the concentration, the reaction will move backward, so that's also wrong. So only option B is the right option. The equation for the manufacture of ethanol is shown here. What is the effect of doubling the pressure on this reaction? So if we double the pressure, let's see it will favor which side. This one, we have 2 moles, and here we have 1 mole. If it means if we increase the pressure, it will favors the production of ethanol, right? So let's see now one by one. Decrease the rate of the formation of ethanol. That's wrong. Doubling the pressure will favor ethanol. Increase the yield of ethene. Again wrong. It will favor ethanol only. Increase the yield of ethanol. Yes, this option is right. So option D is correct. Question 36. The reversible reaction shown takes place in a closed system at a constant temperature. When the reaction has reached equilibrium, more T is added. After the addition of T, which other substances increase in concentration? So where is T? T is in the product. It means if you increase the T, you will get more reactants, right? The reaction will shift towards the left side. So P, Q, and R concentration will now increase. Where is P, Q, R? Yes, C option is the right option. Question 37. The equations show represent a reaction at equilibrium. M and N represent the balancing the numbers of the reactants and the products respectively. A high temperature increases the concentration of Q. Okay, so if the concentration of the Q is increased with high temperature, what does it mean? It means the forward reaction is endothermic. A high pressure increases the concentration of the Q. Okay, so if high pressure is increasing the concentration of the Q, again high pressure and high temperature, so high pressure means that the N is smaller. N is smaller than M, right? M is the bigger number of moles. So let's see now which statement about the reaction is correct. The forward reaction is exothermic. Wrong. So these two options are wrong. The forward reaction is endothermic. Yes, right. The forward reaction is endothermic. And M is greater than M. M is greater than N. Yes, that option is right. That's why it is favoring the concentration of Q when you increase the pressure. So option C is the right option. Question 38. The graph shows how the yield of the product in a reversible reaction changes as the temperature and the pressure are changed. All reactants and products are gases. Okay. So which row is correct for this reversible reaction? First of all, here let's see the yield of the product. Okay, when the pressure was lower, the yield was very high, right, for both the reaction. But for 300, it was more, right? If you increase the temperature, it means the yield is higher. What does it means? That it means the forward reaction is endothermic actually. That's why increasing the temperature is favoring the forward reaction. You are getting more product. But what about the pressure? If you are increasing the pressure, if you see the pressure is increased, the yield of the product is getting smaller in both the reaction. What does it mean? It means the product number of moles are more. That's why if the number of the products are moles, they are not favored by high pressure. So that's why, let's see now the side of the reaction with fewer moles. Which side has fewer moles? It means the reactants have the fewer moles here, because high pressure is actually helping the reactants. We are not getting more product. So that's why reactants, the side of the reaction with fewer moles are actually the reactants, not the product. And forward reaction is exothermic or endothermic? Of course, it's endothermic. So option B is the right option. Question 39. Ammonia is made by reacting nitrogen with hydrogen. The equation for the reaction is shown here. The forward reaction is exothermic, which changes in temperature and pressure decrease the yield of ammonia. So now we have to decrease the yield of ammonia. What does it mean? It means we have to reverse the reaction. Okay, so which conditions will favor it? If the forward reaction is exothermic, then the backward reaction will be endothermic. So it means if we want the endothermic reaction, we have to decrease the yield of ammonia. So what we can do, we can increase the temperature. If you increase the temperature, it will decrease the production of ammonia, because exothermic don't favor high temperature, right? So we can increase the temperature. So these two options are right. And what about the pressure? So pressure, if we increase the pressure, it will help the one that is less. Okay, of course, ammonia has only 2 moles. So what we can do, we can also increase the pressure. So increasing the pressure will do what? If you increase the pressure, it will help ammonia, right? So we should not do increasing in the pressure, we should decrease the pressure. Because if we decrease the pressure, it will help the one that is more in number. So it will again help the reactants, and we have to decrease the yield of ammonia, right? So it will help the reactants. So that's why we can decrease the pressure and we can increase the temperature. So option C is the right option. Question 40. The reaction used to manufacture ammonia from nitrogen and hydrogen is reversible. Equilibrium can be established between ammonium, nitrogen and hydrogen. Okay, so now here the equation is not given, so we can write ourselves the equation. Okay, that is the equation now. Okay, now we already know the forward reaction is exothermic. Okay, so let's see which statement describes the equilibrium. Both the forward reaction and the backward reaction have the same rate. Yes, at equilibrium, both the forward and the backward reaction are at the equal. So that is the right option. But still we can see the rate of the backward reaction is greater than the rate of forward reaction. Wrong. Equilibrium means both are equal. The rate of forward reaction is greater than the rate of backward reaction. Again wrong, because they should be equal. The forward and backward reaction have stopped. Wrong. In equilibrium, the reaction continues but at the same rate. So that's why option A is the right option. Question 41. Ammonia is produced by the Haber process. The equation is shown. The forward reaction is exothermic. Which statement is correct? Increasing pressure decrease the yield of ammonia. So if we increase the pressure, it will help the one that is less in number, and ammonia is less in number. So it means increasing pressure will increase the yield of ammonia. That's wrong now. Okay, increasing temperature decrease the yield of ammonia. Yes, increasing the temperature will decrease the yield of ammonia, because ammonia, this reaction is exothermic. So if you increase the temperature, it will decrease the yield of the ammonia. So this option is right. Let's see now. Increasing the concentration of the hydrogen and nitrogen result in a lower yield of ammonia. Wrong, because if you increase the reactants, the product will be increased. So increasing the temperature increases the yield of ammonia. That's wrong. Increasing the temperature will decrease the yield of ammonia, because this reaction is exothermic. So only we are left with this option. Option B is the right option. But if you see, increasing the temperature decrease the yield of ammonia but speed up the reaction. Yes, the reaction will be speed up, because temperature also can increase the rate of reaction. So rate of reaction will be faster, but the yield of ammonia will be lower. So option B is the right option. Question 42. Nitrogen, hydrogen and ammonia gases are placed inside a container. The container is then sealed. After some time, an equilibrium is formed. Which statement describes the equilibrium in this container? The amount of the ammonia remains constant from the moment the container is sealed. That's wrong, because in start maybe the ammonia was less, but later it becomes more, and then a time came when the equilibrium was reached. So this is not right. The amount of ammonia, nitrogen and hydrogen in the container are always equal. No, that's not right, because both sides, if you see, hydrogen is 3 moles, nitrogen is 1 mole and ammonia is 2 moles. So the numbers are not equal. The rate of the formation of ammonia is equal to the rate of the decomposition of the ammonia. Okay, yes, that's right. The rate of the formation of ammonia is equal to the decomposition of the ammonia at equilibrium. Yes, so that option is the right option. Let's see the fourth. The rate of formation of ammonia is faster than the rate of decomposition. Wrong, because at the equilibrium, both the rates are, the forward and reverse are equal. So option C is the right option. Question 43. Nitrogen reacts with hydrogen to form ammonia in the presence of an iron catalyst. The reaction is reversible. Which statement about this reaction is correct? The iron catalyst decreases the activation energy of for only the forward reaction. Wrong. The catalyst will decrease the activation energy of the both the reactants, both the reactions, reversible and also forward. When equilibrium is reached, the forward reaction has stopped. Again wrong. It never stopped. When the pressure changes, the concentration of the ammonia at equilibrium remain constant. Wrong. If you change the pressure, the equilibrium will move towards the right. Okay, so equilibrium will move towards the right and the concentration of the ammonia will increase. Nitrogen and hydrogen never completely convert to ammonia. Yes, this option is right because in reversible reactions, the decomposition of ammonia and the formation of nitrogen, decomposition of ammonia and the formation of ammonia are at the same rate, right? So nitrogen and hydrogen can never be completely converted to ammonia. So option D is the right option. Okay, let's see question 44. In the Haber process, an equilibrium is established. The forward reaction is exothermic, which changes to the reaction condition will move the position of equilibrium to the left. So what does it mean? We have to shift the position of the equilibrium towards the left side, right? So when we have to shift the equilibrium toward the left side, it means we need the reactants. We don't want the product. So the forward reaction is exothermic. So it means the backward reaction is, the reverse reaction is actually endothermic. So it will be favored by high temperature. So if you increase the temperature, it will favor this reaction. So can you see any increase in temperature? No, we cannot see. So let's see now about the pressure. So we have 4 moles of the ammonia, 4 moles of the and reactants here and only 2 moles of the ammonia, right? So it means if you increase the pressure, it will help the ammonia, but if you decrease the pressure, it will help the reactant, and we have to shift the equilibrium towards the left. So it means we should do what? We should decrease the pressure. If we decrease the pressure, then it will favor the production of the reactants. So decreasing the pressure, yes, that's option is the then right option. Okay, so that's why option A is the right option. Question 45. Which statement about the Haber process are correct? So Haber process, there are two. We have two processes, Haber process and the contact process. Haber process is the production of ammonia. So let's see. A high temperature is used because the reaction is slow at room temperature. Yes, we use high temperature for Haber process because the Haber process use 450 degrees Celsius temperature. So the increasing in the temperature is just because to increase the speed of the reaction. A high pressure is used because there are more moles of gaseous reactants than the moles of the gaseous product. Yes, that's right. If you see here, we have more number of the reactants compared to that of the product. So option 2 is also the right option. A nickel catalyst is used to increase the rate of reaction. Wrong. The nickel catalyst is not used to increase the rate of reaction. It's actually the iron catalyst. Let's see fourth. An iron catalyst is used to increase the equilibrium yield of ammonia. Wrong. A catalyst only increases the rate of the reaction or the speed of the reaction, but it has nothing to do with the yield. Right? So only option A and 2 are the right option. So option A is correct. Which statement about the Haber process are correct? One of the raw material is extracted from liquid air by the fractional distillation. So what are the reactants of Haber process? Of course, nitrogen and hydrogen. So from where we are getting the nitrogen? Of course, from the air. Air has the maximum amount of the nitrogen. So the nitrogen is coming from the air through the process of fractional distillation. And one of the raw material, the second one is hydrogen, right? It is produced by the reaction of steam and methane. Yes, if you look at your books in the chapter 9, you will see that the hydrogen is coming from the steam and methane reaction. So both the options are right. The catalyst for the Haber process is vanadium oxide. Wrong. Vanadium oxide is a catalyst for the contact process. For Haber, it's the iron catalyst. So option 1 and 2 are only the right option, that is B. Question 47. The formation of sulfur dioxide is a reversible reaction. The equation is shown here. The forward reaction is exothermic, which condition produce the highest equilibrium yield of sulfur trioxide. So if the reaction is exothermic, it means we have to give low temperature. So option B or D can be right. And what about the pressure? So we have more number of moles in reactant. So it means that if you increase the pressure, it will help the product, right? So increasing the pressure and lowering the temperature. So low temperature and high pressure, option B is the right option. Question 48. In the contact process, sulfur dioxide is converted into sulfur trioxide in a reversible reaction. The forward reaction is exothermic. Which conditions give the highest yield of sulfur trioxide at the equilibrium? Again, if it's exothermic, only low temperature will help us getting high yield of sulfur trioxide. So now the pressure should be more, okay, because we had less number of the moles of sulfur trioxide. So high pressure will help the more production of sulfur trioxide. So which option has high? Of course, option D. So 1.5 atmospheric pressure and low temperature will help this reaction. So option D is the right option. Question 49. The following reaction has reached equilibrium in a closed system. The forward reaction is exothermic. Again, same. Which row shows the effect of increasing the pressure on the equilibrium mixture? So we increase the pressure, we will get more sulfur dioxide, okay? Increasing the pressure also increase the rate of the reaction. So the reaction rate will also increase, yes, okay, A and B. And the amount of SO2, SO2 will decrease, yes, because if you increase the pressure, it will help the product, right? So amount of the SO2 will decrease, but amount of SO3 will increase. So option A is the right option. Question 50. Sulfur dioxide reacts with oxygen at 2 atmospheric pressure. The forward reaction is exothermic. The reaction reaches equilibrium. The pressure is then doubled. Okay, so when we double the pressure, of course, it will again favor the less number of moles, that is our product. So how and why does the amount of sulfur trioxide form change? So what will happen to the sulfur trioxide amount? It will double, right? It will increase. So C and D options are the right option. Why C and D is right? Let's see. The forward react because the forward reaction is exothermic. The pressure has nothing to do with the exothermic and endothermic reaction. Let's see now for the D option. So it's mean D is the only right option. That is, there are fewer molecules on the right. Yes, that's why if you increase the pressure, it will always favor the one that has less number of molecules. SO3 had less number of molecules on the right side. That's why increasing the pressure has helped to increase the amount of sulfur dioxide. Option D is the right option. Question 51. Sulfur dioxide is converted to sulfur trioxide in the contact process. And these are the conditions which row describe and explain the effect of changing conditions on the rate of the reaction. If you use no catalyst, yes, okay, what will happen? The effect on the rate will be lower. Yes, the rate of reaction will be lower. And why lower? Because the activation energy is higher. Yes, if there is no catalyst, then the activation energy of the reaction will be higher. So that's why option A is the right option. So we can choose already the option A. Question 52. During the manufacture of sulfuric acid, sulfur dioxide is converted into sulfur trioxide. Which type of reaction is this? If you see here, displacement, no, nothing has been displaced from its place. So neutralization, of course, it's not an acid-base reaction. Oxidation, yes, that option is right because oxygen is added here, right? So this is oxidation reaction. Also not thermal decomposition because nothing has broken down. It's actually making up, right? So oxidation is the right option, option C. 53. Okay, again the reaction. The reaction is exothermic. Which of the changes shifts the equilibrium to the right? So right means we will get more sulfur trioxide. Increasing the concentration of oxygen. Yes, if you increase the reactant, you will get more product. And product is on the right, right? So that's right. Increasing the pressure. Yes, it will also help the one that is less in number. So SO3 is less in number. That's also right. Increasing the temperature. That's wrong because exothermic is not favored by high temperature. So option 1 and 2 is only the right option. That is option B. Question 54. The formation of sulfur trioxide, again the same. The forward reaction is exothermic. Which changes would increase the yield of SO3? Again, let's see. Increasing the pressure, yes. Lowering the temperature, of course, yes. And decreasing the concentration of oxygen, that's no. Because if you decrease, it will move towards the left side. So 1 and 2 are only the right options. So that is option B. 55. The contact process, again, they have shown you the forward reaction is exothermic. Which statement about this process are correct? The catalyst increases the rate of both the forward and backward reaction. Yes, it increases the rate of both the forward and backward. A low pressure increases the yield of sulfur trioxide. Wrong. An increase in pressure will increase the sulfur trioxide. Okay. A low pressure is used to keep the cost low. Yes, usually for industrial process, the pressure is kept low to decrease the cost. So option 1 and 3 are right. A high temperature increase the yield of sulfur trioxide. Again wrong, because this is exothermic. So increasing temperature will not help. So 1 and 3 are the only right option. That is option B. Question 56. Sulfuric acid is manufactured using the contact process. One of the reaction is shown here. The forward reaction is exothermic. Let's see now one by one these statements. The equation has more molecules on the left hand side than on the right hand side. Yes, the equation has more molecules on the left hand side than the right. Using a high pressure shifts the equilibrium to the left. If you use the high pressure, it will move towards the right because we have less number of moles. So it means this statement is wrong. Statement 2. High temperature increases the rate of reaction. Again wrong, because it's exothermic. So exothermic, low temperature will increase the rate of reaction. Statement 4. Increasing the temperature shifts the equilibrium to the right. Again wrong. Okay, because increasing the temperature will not shift the equilibrium to the right, it will shift towards the left. Oh, sorry, the statement 3 is right. High temperature increase the rate of reaction. Yes, it will increase the rate of reaction, but it will not increase the yield. So that's why equilibrium will not be shifted, right? But it can increase the rate of reaction. So option 1 and 3 can be right. Can we see here? Yes, option B is the statement. Option B is the right, because statement 1 and 3 are correct. 57. Which row shows the conditions used for conversion of sulfur dioxide to sulfur trioxide in the contact process? So for this, you have to memorize these conditions. For contact process, the catalyst is always a vanadium oxide. Okay, iron is the catalyst for Haber process. Okay, so 1 or 2 can be right. Now let's see about the temperature. Temperature is 450 degrees Celsius always, and the pressure is 28 atmospheric pressure. So option B is the right option. 58. Which row shows the condition in the contact process? Again, the same question, but the pressure is 2 atmospheric. Yes, temperature is 450, and vanadium oxide. Okay, if it is written 200 here and here it is written kPa, then this option would be right. But they ask you the pressure in atm, so be very careful when you look at the question in exam. If it's atm, then it will be 200, but if it's if it will be 2, and if it is kPa, then it will be 200. Okay, so that's why option C is the right option. Question 59, again the same. Now here they are asking about the pressure in kPa. So you see here the temperature is same, 450, 200 kPa pressure, and vanadium oxide. So that's why option C is the right option. Question 60. Which row identifies the pressure and the catalyst used for the conversion of sulfur dioxide? Again in the contact process. So the catalyst is vanadium oxide, right? And now what about the pressure? So they are asking in atm, right? So that's why option B is the right option. Question 61. Which substance is a raw material used to manufacture sulfuric acid? So for sulfuric acid, we need sulfur dioxide to be converted into sulfur trioxide. But sulfur dioxide is an intermediate. It's not a raw material. Raw material is something that we are getting in the raw form, right? So that is sulfur actually. So sulfur is the one that will produce sulfur dioxide. So option B is the right option. Question 62. The Oswald process is used to make nitric acid. The conditions used in this process are catalyst, a pressure of 10 atm, and a temperature of 800. Which of these conditions are used in contact process? So only option 1 is right, because in contact process we are using vanadium oxide, and that is an oxide of the transition metal, right? So a catalyst that is we are using in the nitric oxide is also a transition element. So option B is the only right option. That is statement 1, right? Question 63. Ammonium sulfate is used as a fertilizer. It is made from ammonia and sulfuric acid. Which words complete gap 1, 2, and 3? The dash is made by the dash process. Let's see. Okay, ammonia is made by Haber process. It means B option can be right. Sulfuric acid is produced by contact process. Yes, so C option can be right. So these are the only B or C can be right. But let's see now about the catalyst. Dash is used as a catalyst. For ammonia, it's a Haber process, and the catalyst iron. So this option is wrong. Now we are left only with option C. Sulfuric acid is made by the contact process, in which Vanadium oxide is used as a catalyst. So option C is the correct option. Question 64. Fertilizers are used to provide three of the elements needed for the plant growth. So you have to remember what are those three important elements that are NPK. That's why we call those fertilizer NPK fertilizer. What does it mean? Those fertilizers which have nitrogen, phosphorus and potassium in them. Okay, so which two compounds would give a fertilizer containing all the three of these elements? So you have to look for nitrogen, phosphorus and potassium. We have nitrogen here, but no phosphorus and potassium. Nitrogen, yes, we have phosphorus, but no potassium. Potassium and nitrogen, no phosphorus. Potassium, nitrogen and phosphorus. So option D is the right option. So that's all for today's lecture. See you tomorrow. Bye-bye.